Today we will work on day 5, which is writing rational equations, and we're going to do that by applying what we have learned to word problems. So let's take a look at our first problem. It says Julia has made 12 free throws out of 26 attempts in her basketball games this season. If she can raise her free throw percentage to 60%, she will tie her record from last season. How many consecutive attempts will she have to make in order to reach a free throw percentage of 60%? Write a function to complete the problem. So let's circle important numbers. So she made 12 out of 26 attempts. We're wanting to know what she's going to need to raise her percentage to 60%. Let's underline our question. How many attempts, consecutive attempts, will she have to make in order to reach that percentage of 60? So I'm going to let x represent some number of consecutive attempts. Consecutive meaning one right after the other. So we're going to make a fraction, 12 out of 26 attempts. And then she's going to shoot some number of consecutive attempts. So we're going to add x to top and bottom because she would be, every time she shoots, that adds to her total, which gives her a chance to make another one. And we want that to equal 60% as a decimal. We would move it over to the left twice. So we want that to equal 0.60. Okay. I'm going to make this a fraction, and then I'm going to solve this by cross multiplying. So I'm going to have 0.60 times 26 plus x, and then 12 plus x times 1 would still just be 12 plus x. So when we distribute here, this is going to give me 15.6 plus 0.60x. And we're going to solve this for x. So we would subtract that's going to leave me 15.6 equals 12 plus 0.40. I'm going to subtract 12. That's going to give me 3.6 equals, forgot my x there, 0.40x. We would then divide. And when we do that, you're going to get x equals 9. So 9 consecutive attempts. Every word problem is different, so it's just going to take you getting used to what type of problem it is. It's always important to circle important numbers, underline that question so you don't forget what you're answering. Number 2 is a different problem. It says Mo and Marco deliver a regular order to a specialty food store. Mo can unload the truck in 40 minutes if he works alone. So I'm going to circle that. Mo and Marco can unload the truck in 15 minutes together. How many minutes does it take Marco to unload the truck if he works alone? So there's our question. Assume both men work at steady rates and their rates are not affected by either working alone or working together. So I'm going to set this up like this with each person. So it tells us Mo can unload one truck in 40 minutes. So one truck in 40 minutes. It also told us that both men together can unload one truck in 15 minutes. The question asks us how many minutes does it take Marco? So how many minutes for him to unload one truck? Since we don't know, we're going to call that X minutes. So if you think about this, Mo plus Marco equals both men together. So now let's fill in what we know. We know Mo is basically 1/40. Marco is 1/X. And then both men was 1/15. So now if you think about getting our least common denominator, like we were before, we would have a 40, an X, and a 15 for our least common denominator. So for this denominator, we need an X and a 15, so I'm going to write that as 15X. Here, we need 40 times 15. And here we would need 40X. So now we're ready to make our equation. If you refer back to yesterday's lesson, so you've got 15X plus 40 times 15 is going to give us 600 equals 40X. We'll subtract 15X. That's going to give us 25X when we do that. You divide by 25. And you're going to figure out when we divide that, that's 24 minutes. And then just make sure that you are actually answering what the question asks for. How many minutes does it take Marco? If you go back over here to how we labeled Marco, X does represent his minutes. So you're finished with that problem. The next one says a new street sweeping machine can sweep a town street in 20 fewer hours than it takes the old machine. So the new machine is 20 fewer hours than the old machine. Working together, the two machines can complete the job in 24 hours. How long does it take each machine to complete the job? Working alone. Assume the machine's rates are not affected by whether one machine is used or both machines are being used. So again, we're talking about the new machine, and it says it can sweep one street 20 fewer hours than the old machine, and then it talked about both machines together. So I don't know how much the old machine, so 20 fewer hours than the old machine would be X minus 20 hours. The old machine is just going to be over X hours because we don't know anything about the old machine. But then we do know that both can complete the job in 24 hours. So one street in 24 hours. I'm just going to abbreviate there again. So again, new plus old would equal both machines together. So let's solve in what we know. So we have 1 over X minus 20 plus 1 over X equals 1 over 24. So again, I'm just going to come to the side for my least common denominator. I would need one of each, so an X, 24, and X minus 20, if you want to think of them separately. So if you compare this denominator to this, we would need a 24X. Here you would need a 24 and an X minus 20. And then here we would need an X and an X minus 20. So all denominators are the same. So I'm going to go across and I'm going to circle all the numerators to create my equation. So we're going to have 24x plus 24 times x minus 20 equals x times x minus 20. So I'm going to distribute. That gives us minus 480 equals x squared minus 20x. Okay, so I recognize that this is a quadratic, so I'm going to set my quadratic equal to 0, and I'm going to do that by subtracting everything over. This is going to become 48x minus 480 equals x squared. So we're going to subtract 48x. I'm going to add 480. All that goes away. So we're going to have x squared minus 68x plus 480. And then we're going to factor that with AC. So for time purposes, I'm going to help you out here. So factors of 480 that are going to add to negative 68 are going to be negative 8 and negative 60. So I'm going to come up here with this, and we're going to have x minus 8 times x minus 60 equals 0. So again, you would set each piece equal to 0 and solve. So we got x is 8 and x is 60 when we solve those. But you got to go back and wanted to know each machine. So our new machine would be, if I took 8 and went here, 8 minus 20 would give me negative hours. So I'm going to have to use 60 here. So our new machine would be 60 minus 20 for 40 hours. And our old machine is just going to be 60 hours. And we're going to cross this out because this gives us negative hours. So here's our answer.